Welcome to my class Physics by Learn Science. And in this class, we are going to learn and practice various problems based on the graphical representation of motion, which is from chapter Motion, class 9. So, the type of problems which we will solve in this video lesson using DT graph and VT graph are to find the speed and velocity of a body, to find acceleration, to find displacement, and also we are going to predict the type of motion by looking at the graph. We know that every problem has a solution, and to find a solution we need to use right method. So here we are going to first learn the two tools which we will use to solve graphical based problem. So first is our slope and second area under the curve. So let us understand first what is slope and how to find it. So slope of any graph tells us the steepness. For example, if we have a graph which is given on your screen, so for this graph, this theta will help us to determine the slope. And how to find the slope? For that, we can take any 2 points in this graph. Let us say I have taken point A and point B. And then next, we are going to draw a line which is parallel to y-axis from point B and another line which is parallel to x-axis from point A. So now we got a right angle triangle. So let us say this is also angle theta because these two angles are corresponding angles since AC is parallel to x-axis. Now we know slope is tan theta and tan theta is perpendicular by base. So in this triangle, the side which is opposite to theta is perpendicular and attached to theta is base. So that means BC upon AC is my slope in this triangle. And what will be the length of BC and AC that we can determine with the help of y-axis and with the help of x-axis. So for example, for y-axis, this point is y1, let us say, and this is y1 and this is y2. This is x1 and x2. So that means my slope here is y2 minus y1 upon x2 minus x1. Next, let us also try to understand how to find area under the curve. So area under the curve in this graph is basically the region between x-axis and the graph. Suppose this is my x-axis and this is my y-axis. So the region between x-axis and and this curve is my area which I need to calculate to find the displacement in the upcoming problems. So that means this region will give me my displacement. So here let us say A, B, C, D are the four corners of this shape and the shape here is trapezium. So area of trapezium is equal to half into sum of parallel sides into height. So in this case my sum of parallel sides are AB plus CD as these two sides are parallel into height and here the height is AD. Next, if the graph is like this, then this region will give me the area and we can see it has shape of triangle. So in this case, we are going to find area of triangle which is equal to half base into height. So in this case, if these points are A, B and C, so my base here is AC and my height is BC. And suppose if our graph is like this, then in this case, my region which I have to find area is this. And let us say this is A, this is B, this is C and this is D. So in this case, my area of rectangle is equal to length into breadth and here my length is BC and my length is BC and my breadth is CD. So BC into CD will give me the area of rectangle. So by this we can find area and with the help of area we can find displacement of a body especially when the graph is given Vt. It is time to solve our problems. So let's start with problem number 1. So in problem number 1 it is given to find acceleration, velocity and distance covered body in 15 seconds. So let's find it one by one with the tools which we have discussed earlier. So first we are going to find acceleration. Now we know acceleration we can calculate with the help of slope of a graph And in this case, in this graph, you can see there is no slope. So that means my slope is 0 since the line is parallel to time axis. And if slope is 0, it means my acceleration is also 0. So it means my acceleration is 0 meter per second square. And we can see easily this in this graph. Since velocity is not changing with time, it means my acceleration is 0. Now next I have to find the velocity. So let's find the velocity of a graph in this body in this graph. So velocity you can see here is 20 meter per second. So that means my velocity is 20 meter per second. Now third, let's find distance covered by body for first 15 seconds. So distance for first 50 seconds, that means I have to find distance from 0 to 15. So let's see the area which we are going to find here is this. So this region will give me distance covered by body, and let's name the point as A, B, C and D. The distance here is area of rectangle A, B, C, D. So we know rectangle area is length into breadth, and here my length is AD and my breadth is AB. So AD is 15 and AB is 20. So 15 into 20 gives 300, and this is distance, so I am writing meter. So distance covered by body in first 15 seconds is 300 meter. So that's our problem number 1. Now let's go to the next problem, that is based on again on velocity time graph. So the velocity time graph of an ascending passenger is given below, and what is the acceleration of the lift for first 4 seconds between 4th and 8th second. So let's do this. So for first 4 seconds, let's find the acceleration. So first let us try to understand which slope is giving me for, or which line is for first 4 seconds. So if you see in this graph, so my graph in this graph, my first 4 seconds is 0 to 4. So that means for 0 to 4, if I will see this line, okay, this line is telling me the slope for the first 4 seconds. So let us say this is A, this is B, this is C and this is D. So first for first 4 seconds I have to find the slope of AB. So slope of AB, first let's calculate for the first 4 seconds. So slope of AB here is, let us take 2 point first. So I am taking 2 point A and B, and let's draw a line parallel from point B and the line from A. So we got a triangle, and let us say this is my angle theta, and let's this point as E. Okay, so slope of AB here will be tan theta, and tan theta here is perpendicular by base, we know. So perpendicular in this triangle is BE and my base is AE. So BE here is, if you see, it is 20 and length of AE is 4. So that means my acceleration is 5 meter per second square. So acceleration for first 4 seconds is 5 meter per second square. Next, in second case, I have to find acceleration when the body for the time interval 4th and 8th second. So if you look in the graph, my 4th second is here and 8th second is here. So that means I have to find this slope for BC. So slope for BC is 0 since BC is parallel to AD. So slope of BC is 0 because it is parallel to time axis. Therefore, my acceleration here is 0 meter per second square. I hope it is easy peasy. So now let's move to the next question. Problem number 3. In problem number 3, the graph is given below is the velocity time graph for a moving body. We are going to find velocity of a body at point C. So let's see what is the velocity at point C. So this is my point C and my velocity here is, if you can see, is 30 meter per second. So that means answer is 30 meter per second. Now the second, we have to find acceleration acting on the body between A and B. So that means I have to find this reason, slope for this AB. So let us find the slope. So for this, again, I'm going to draw a line which is parallel to y-axis from point B. Another line parallel to x-axis from point A. And now I got my perpendicular and base. So this is my angle theta. So the slope is making angle theta with x-axis. And this point is, let us say, is O. Okay. And this is my perpendicular and this is my base. So acceleration here we know is slope. That means slope here is tan theta. Okay. So tan theta is equal to perpendicular upon base. So here I'm solving question number 2 here, part 2. So acceleration will be perpendicular by base. So perpendicular here is BO and base here is AO. So length of BO we can find with the help of y axis. So it is 30 minus 10. So 30 minus 10, and AO we can find with the help of x-axis. It is 0 to 3. That means 3 minus 0. So it is 20 upon 3. That is equal to 6.6 bar, or we can write as 6.7 meter per second square. So that means acceleration of a body uh, for A to B is 6.7 meter per second square. Now let's find the acceleration of a body between B and C. So we can easily find it. See, we can see that B to C, this line is parallel to x-axis. So here my acceleration will be 0 because my slope is also 0. So I hope it is clear to everyone. So for third, my answer is acceleration is 0 meter per second square since the slope is 0, since there is no slope. So easily we calculated with the help of slope and area. So with the help of slope we are calculating acceleration, and with the help of area we can calculate displacement of a body. Now let's move to the next question. So our next question is problem number 4. So in this question we have been given four graphs for car A, B, C, D. So we have to find the correct statement. So let's see. So we can see easily here from the graph that the speed will be more if the slope is more. So in this case, if you compare the slope of all the graph, so that means, let me write here, slope of C is greater than slope of D is greater than slope of A is greater than slope of B. So that means we can say car C has a maximum speed. So it has a maximum speed. And now let's choose the correct statement. So car A is faster than D. So if we can see the graph, since the slope of A is less than slope of D, so this statement is wrong. Car B is slowest. So I can say here the slope here is, it has a least slope or a minimum value. So the angle theta is has a minimum value in this case. So I can say the statement is correct. Now next it is said that D is faster than C. So the statement is also wrong. We can see here. Then next is car C is the slowest. This is again wrong because we have already seen it has a maximum speed. So our correct statement in this case is car B is the slowest. Now let's move to our next question. Okay, so in this question, we are going to predict the type of motion by the following graphs. So let's see and recall what we have learned till now. Using that, we are going to tell which type of graphs are this and which type of motion they are representing. So first graph is DT graph. So in DT graph, we can see this line is parallel to time axis. It means position is not changing, and we can conclude that the body is at rest. Next, second graph, you can see the line is straight and it is again a DT graph. So we are getting a slope and the line is straight. It means the body is moving with uniform motion. So it is covering equal distance in equal interval of time. And third graph, you can see the graph is not straight, so it is non-uniform motion. So third graph is for non-uniform motion. Now let's talk about the fourth graph. Now fourth graph is my VT graph, and again we can see the line is parallel to the time axis. And as you can see, velocity is not changing with respect to time and it is constant. So we can say, so it has uniform velocity. So body has uniform velocity, and when velocity do not change, it means there is no acceleration. So acceleration also here is 0. Now in the next case, if you will see, again is a velocity time graph, and the line or the graph we are getting is a straight. So that means it is again an example for uniform motion, and basically this is a VT graph, so it means it is uniform acceleration. And the third one is, last one is non-uniform acceleration. I hope it is clear to everyone. Now, can you guess whether this is possible or not? If yes, let me know about it. And by this, I'm going to end this lesson. So thank you. Bye. And please don't forget to like, subscribe, and share. Bye bye.